So now into the next, this session, you see that now we have the equations and these are basically your exam like questions. Okay. अब देखिए, you have to solve these equations now. Let me have some space for these. Let me cover this as well, okay? So I'll be starting from this question number. Uh, okay, this question number 5. It says you have 3 cos 2x plus 17 sine x equal to 8. It says find the exact value of sine x. Okay, so this is 3 cos 2x plus 17 sine x, that is equal to 8. Now you remember this is a very important formula of this cos 2x, which is cos square x minus sine square x. And this cos 2x can be written either in the form, purely in form of the sine, which is 1 minus 2 sine square x, and you can also write it as 2 cos square x minus 1. Right now for this form, this particular equation, we'll be needing this identity because he wants us to give the exact value of sine x, this sine x, okay? So we need to change this cos 2x into the sine wali form. So this is 3 into 1 minus 2 sine square x, and then you see this is 17 sine x. You can move this to the left hand side. This is 3 minus 6 sine square x plus 17 sine x. If you're afraid of this form of the equation, you should immediately say that let this sine x equal to anything. Let's put that equal to y. So this is going to be uh, 3 minus 8 is minus 5, okay? And 17 sine x is going to be 17y, and this is minus 6y squared. We can write it as 6y squared minus 17y plus 5. I think I can factorize this. 15 2s are 30, है ना? So 6y squared minus 2y minus 15y plus 5. So we factorize. So it's 2y into 3y minus 1. This is minus 5 into 3y minus 1. So we have 3y minus 1 into 2y plus 5 equal to 0. So you have the two values of y. One of the values of y is 1 over 3, and the other is minus 5 over 2. These are the exact values of, he was asking.
ये 2y minus 5 नहीं है,
Yes, just
फिर आपने plus 5 लिखा है.
thank you. Okay, so these are the two values of your sine x. So sine x is either 1 over 3 or your sine x is 5 over 2. Acha, अब देखिए, the same kind of questions are going to be like onwards, 5 onwards. Look at this, the same kind of equations are there, but you're given x from 0 to 360. Suppose the same question said that solve this equation between 0 and 360. So when you reach over here, then you have to say, okay, look, this is sine x, which is 1 over 3. So this means that if your sine x is 1 over 3, then we can say, okay, look, we are going to be into the first two quadrants because sine is positive for this sine x equal to 1 over 3. So you will find the basic angle. Please tell me what is sine inverse of 1 over 3? What is sine inverse of 1 over 3?
Sir, but they asked for
The
the exact value of
19.47.
Yeah, beta, what?
19.47.
Okay. So this is your x, one is 19.5 and the other one is going to be 160.5. Yes, so these are the two solutions for this x, and for this there will be no solution because now you must remember that sine and cos they exist between 1 and -1. So these will be the two solutions for this equation if we had to solve this completely, finding the values of x. Okay? In this question, it was stated that we have to find the value of sine x instead. So if it was just sine x, we could have stopped up to this, okay, na? But I've just added something into this question. Okay? You can look at question number 6, that now you have the equations. Let me clear all of this. If you look at these questions, like it says, it's saying here that uh, solve the equation for this. So when you have to solve this equation, remember the whole
Sir,
equation. Yes, beta. Uh-huh. Yes, beta. There's someone saying sir and not saying anything after that. Mhm. Look at this 6a. You have, I can't hear that, this student. Okay, look at this. So I can't hear you, but please text that. Okay, this is 2 sine 2 theta, that is equal to cos theta. So we have, first of all, we have to get rid of these different angles in the same equation. Okay, we shouldn't be having this. So I'll be using that sine double angle formula here, that sine 2 theta is going to be 2 sine theta cos theta. So let's change that with this. So this becomes 4 sine theta cos theta, that is equal to cos theta. What should be our next step, bacho? Should we cancel the cos theta with the cos theta?
No, sir.
Yeah, never. If you can take that common, you should do that. So this is 4 sine theta cos theta minus cos theta equal to 0. So let's take cos theta common here. It's better to put that into the brackets. 4 sine theta minus 1. So you have two relations from here. One is cos theta equal to 0. Let's solve that. That is going to be cos is 0 at 90 and 270. Yes. And then the other relation is 4 sine theta equal to 1. And your sine theta is going to be 1 over 4. You quickly mark the quadrants where it is going to be. So what is sine inverse of 1 over 4?
14.
Is 14.47. So let me write it as 14.5. This is 14.5. So your theta is 14.5 or 165.5. So we have three values. Let's write them in an order. It is going to be 14.5, 90 degrees, 165.5, and 270. These are the four solutions of this equation here, which was 2 sine 2 theta cos theta. So remember, first of all, we made the same angle on throughout the equation using the double angle formula, and then we try to bring in one single trigonometric ratio into these equations. Okay? If you look at the C part, bacho, see, you have to decide that uh, because you have
sir,
seen, yes, 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 beta, I am listening to you. Okay, there is nothing followed by sir, so I can't help this, bacha. Okay, look at this C part, bacho. In this C part, you have 2 cos 2 theta plus 1, that is equal to sine theta. So remember, your cos 2 theta has two faces. One is 1 minus 2 sine square theta, and the other is, it is 2 cos square theta minus 1. Okay? So you have to decide that which one of these two identities you will be using here to be able to solve this equation. So which one I should be using? The first one or the second one? Hmm? Yes, but
First one.
yeah,
First
first
one?
one. Yeah, because we have the sine theta over here. So we'll be writing the expression in terms of sine over here. So we have 2 into 1 minus 2 sine square theta, and then you have plus 1. I believe you can do it after this. You can simply say let your sine theta equal to y. So this becomes 2 minus 4y square plus 1, that is equal to y. And that is a simple quadratic equation now. 4y square plus y minus 3, that is equal to 0. And then you can factorize it like this. If you can't factorize this, you must be able to use the quadratic formula, okay? Y plus 1, this is minus 3 into y plus 1. So you have y equal to minus 1, or you have y equal to 3 over 4. And then you put this back equal to the um, sine theta, okay? So then you can say, okay, look, sine theta is going to be minus 1. You know that sine is minus 1 when it is 270 degree, at 270 degrees. So you get one value from here, and then you put that sine theta equal to 3 by 4. Again, like it is the third time we're getting this in the first two quadrants. So what is sine inverse of 3 over 4? That is 36 point something. What is that? Hmm? Uh,
48.6.
48.6. Okay, this is 48.6, 48.6. So this is 48.6 and 131.4. है ना? So we have three values of theta: 48.6, 131.4, and 270. Okay, guys, this was it. If there is any question, please let me know. And now it's your time to practice. Let me show you these questions here. You can move on to this question number 7. You can try 7, 8, 9, 10, 11, 12. All of these questions you should try so that you can master, you can be a master on the trigonometric equations.